Hi, my name is Jack Dangermond, and I really appreciate the opportunity to share with you some of my thoughts about how GIS and geospatial information systems are integrating institutions across the world. You know, you're a very special group of people, the geospatial people, who are measuring our reality in Australia and beyond, being able to put it into information systems that actually bring science right into the world of operations for so many activities. Your work actually is addressing so many challenges, both in Australia, but in the case of some of your organizations around the world. These are interesting applications. They're applications that are applying science to just about everything. And the way that you are doing it holistically and in an integrated way has one of the bright lights for our future in mind. I looked at a few examples of your work that were sent to me up here in California, and I was amazed. In the utility space particularly, you are managing systematically infrastructure better. And part of that has to do with visualization and being able to create what we're starting to call digital twins of all the facilities, the infrastructures, and then visualizing it through, for example, what Snowy Hydro is doing, being able to visualize on a tour all of the facilities at one time. In the more analytic space, some of you are applying GIS to be able to, what I call before you dig, or monitor various interruptions to the infrastructure systematically with maps. These examples show more or less real-time operational dashboards which show everything from invasive species control, like the ACT parks, ACT parks operations, to looking at diseases. In this case, it's looking at diabetes across Australia. And then look at the upper right-hand corner where imagery, satellite imagery, is being taken and classified and applied to various forms of agricultural and tree cover management. This is very exciting. We're moving from an age where GIS is about making maps to the idea of being able to systematically support in near real-time operations of many types. Finally, I pulled out these examples to show from a public safety and emergency management perspective just a couple of maps that are just really fantastic. The world is in trouble, we are told, and these sort of episodic activities like the flood, the 1,000-year flood can be seen here very systematically in the New South Wales flood viewer. And look at the upper right-hand corner where 3 different episodic activities like thunderstorms, floods, and tsunamis were all happening at the same time in a kind of multi-agency platform for sharing and mapping information. These are all examples, small little stories of great work. And I'm very proud to be, in a small way, helping you support some of these activities. Now, look, I promised that I would talk about an integrated vision, a vision for bringing different agencies together. And that is exactly what I intend to do, using GIS as a concept to organize and apply geographic knowledge. This is happening in literally hundreds of thousands of institutions around the world. A kind of new infrastructure is emerging. This is transforming how we understand our world, our countries, our regions, our states, our cities. And it's also helping us better manage operations in an effective way. Some people have called this the emergence of a kind of nervous system for our planet, leveraging the internet and geographic information of many different types. Now, our world, the world that you and I are living in, is being challenged. And my assertion is that some of this has to do with our lack of understanding. If we only knew and we were only able to communicate how things are interrelated and how some of human activities are threatening our very future. Another big challenge is a lack of ability to collaborate among each other. If we look at this image, we see that some of the drivers of overpopulation, well, maybe not so much in Australia, but certainly in certain parts of the world, and also human-induced climate changes are setting in motion so many other phenomena in both the natural and physical world. Things like fire, which you certainly have experienced, drought, flooding, tsunamis, all of these sorts of things are also in turn affecting our human activities, increasing social conflict, more awareness. The pandemics are being suggested as one of the implications of a cluster of changing world activities. I think about what I can do personally, and I'm working very hard at it, planting trees, doing my own little part, using more natural resources that are, like solar energy resources that are renewable, etc. Yet, I think that this isn't going to be enough. We need to mobilize society to collectively be responsible for understanding what's going on and then come up with smart approaches for creating a more sustainable world. And sustainability is certainly possible. We must change our priorities to step it up and make a major commitment to our future. And this means many of these things that I've shown here. It means continuing economic development, of course, but also conservation activities, things like protecting biodiversity, looking at lowering greenhouse gas emissions, creating sustainable land use of many types. From my perspective, your work, GIS, and the idea of applying the geographic approach is going to be significant, and actually, some people say, essential to be able to turn this around. This geographic approach is a kind of way of thinking and problem solving. Many of you do it. It's about integrating geographic sciences and information into how we understand our world and how we manage our nation. This approach is about integrating all the factors. And as the words suggest here, it's science-based and it's holistic in nature. We bring it all together and we provide a framework with a geographic approach of both understanding and applying this knowledge at scale. Some words that people are fond of is the idea of inclusiveness and multidisciplinary processes that impact virtually every sector of our society. And this is exactly the kind of work that you do. GIS enables this geographic approach. It's kind of this diagram I've shown for years, but it's kind of an adaptation of the scientific method of measuring things, assessing, visualizing, analyzing, building hypotheses, being able to create practical solutions out of analytics that allow us to design action and take these actions, proposals into the decision makers who really result in delivering it into action in the field. And whether it's in a utility company or in a city or at a national level, all of these things are fundamental to how we approach the geographic, how we apply the geographic approach. Let me move on here. GIS professionals are already applying this geographic approach. The evidence is the few examples that I showed earlier. In a kind of network fashion, all the kind of work that's necessary to create a more sustainable future is already going on. But it's not enough, obviously. We need to step it up. And this is really where GIS technology and its evolution comes in. I would assert to you that the GIS technology is not only advancing rapidly, but it's also allowing us to integrate and leverage many different innovations that are occurring in our society today. Cloud computing, apps, the ability to use imagery and remote sensing and do AI and machine learning. All of these advances are being integrated into GIS and helping us bring our collective efforts together. And this will be the main thesis of the rest of my talk. Innovations in our field, the big trends in our field, well, there's dozens of them, of course, but in this lecture, I'd like to really focus on these 11. And you can glance through them. and then I will go through them systematically. Let's start with this first trend, that GISs are increasingly becoming interconnected. These patterns of GIS, whether it be on a desktop or in an enterprise server or in the cloud now, accessed by apps and embedded sorts of operations, are getting interconnected with web services. You might describe this as a system of systems. And when we look at a national level, that's certainly what is emerging. We're connecting, streaming information and services from one system to the other. And this supports more collaboration and more integrated sorts of decision making. I'll simply describe this pattern as geospatial infrastructure, and in some regions of the world it's accelerating very fast, and in some sorts of institutions or combinations of institutions it's accelerating very fast, like in cities or in states or in some cases in nations. Historically, we talked about this as a kind of national spatial data infrastructure or spatial data infrastructure. That's exactly what's happening today. And these are enabled in part by open and interoperable technologies, standards, open architectures. The integration of open science and open source tools into these infrastructures is essential. And the evidence that this is emerging in a heterogeneous environment is demonstrated by national agency, local agency collaborations, and these systems of systems coming into being. Now, one element that really enables this is trend number 2, which is a new kind of technology, geospatial technology, I have dubbed a GIS portal. This actually organizes distributed web services in the little cloud shown in this diagram. This agency has open web services. This agency has other kinds of open services or analytic capabilities. These capabilities are organized and made available through portals. You could think of them as like advanced websites. But it's not just a website. It has actually in the portal many hundreds of capabilities for mapping and visualization. The portal technology itself is a kind of little GIS. And I can attach or connect those portals to these distributed services and make a particular community that leverages or integrates those services come alive. On the right, I've shown a few examples of this. In our US government, FEMA, the Federal Emergency Management Organization, brings together services from the national agencies like NOAA and NASA, USGS and so on, as well as services from state and local organizations when a disaster hits. And it brings them together in a portal for use where people can use each other's data effectively. It's not just one agency providing their data, it's federating the data to be able to create a kind of community. Now, this diagram is really important to understand. It's perhaps the most important diagram in my talk today. Because as we build the network of distributed services that are open, it means that we can stand up portals for any community. And we can do it quickly. We can do it in a matter of an hour or two, for example, a particular fire or a particular emergency that really call on the national and regional and state assets or even local government assets, bringing them together for a focused application. This is a kind of new GIS pattern, which is really taking hold and moving very rapidly. There are, fed by ArcGIS Online, as an example of this pattern, over 10 million users that are carrying this kind of function out with tens of millions of data sets that they are sharing and using each other's data sets. And that's making billions of maps every day. This kind of pattern is emerging extremely fast in the service of empowering GIS professionals, but it's also creating a new kind of intelligent infrastructure, like the web itself, which is fueled by all these measurements that are going on from satellites, from GPS, and so on. It's emerging as a kind of platform. And this platform, GIS, integrates many types of data. It's not just a single proprietary data set. No, it's open data with many different types and formats: LiDAR data, imagery data, 3D data, BIM data, textured meshes, or tabular information, and even text. It can be brought together and dynamically georeferenced in such a way that these services can support just about any kind of map or app that's built. Now, speaking about that, another big trend is that GIS is going far beyond just desktops. Desktop tools are fueled by and creating the infrastructure, but there's just massive deployments happening on devices, iPhones, Android devices, and so on, which are connecting field people to the servers and services for both collection and also use of data in a distributed environment. And then web apps are exploding. Actually, millions of web apps. Last year, 1.2 million new web apps were built just even on the technology that I create. One of those was the coronavirus from Johns Hopkins University, which resulted in over 2 trillion map views, so that every citizen was looking at this. So this infrastructure isn't just for scientists or for professionals, it's opening up and educating the world. It's doing it with interactive web mapping. The new generation of web maps is that I not only make a map, but I can actually interact with the map. I can do analytics on the map. I can explore the map and explore the data as a result of this amazing kind of web service. Also dashboards, as we saw earlier in my talk, you're deploying them like crazy. They're monitoring not just viruses or health or forests or water or just about everything. Users are going crazy with this. App builders allow us to build these web apps very quickly. In a matter of minutes, I can build an app. I no longer have to spend $50,000 developing a web app or a mobile app. I can just do some configurations of widgets with basically no code or low code app development. So this is for developers, not just for heavy duty developers, but for everyone being able, they can be their own developers, and that's causing this explosion. The next trend I want to talk about is at the other end of the scale. Spatial analytics rooted in GIS are creating whole new insights, whether it's predictive modeling, like the prediction of where COVID was moving, or currently where the Russians might move next, to spatial temporal modeling, the ability to do also graph analytics, that is to interrelate things in relationship space as opposed to spatial space, is intriguing. Geo AI and machine learning, particularly in the imagery area, is taking off like crazy, and we're learning how to integrate big data as just another data source with GIS. Graph analytics I'll stop up for a moment and explain in greater depth. This is the idea of entity relationship diagrams, like the interaction between people or supply chains or different objects that may exist in space, but independent of space, define their relationships with digital means. Graph databases are sometimes the foundation for this. Also, real-time analytics and visualization are taking hold in major way, being able to stream through whole IoT measurements, not only moving things, but also stationary things like temperatures in rooms or stream flow, that sort of thing. And that's making GIS come alive in real time with dynamic applications. And that's just really beginning. Integration of big data, as I mentioned a moment ago, is moving very fast. Some of this has to do with simply connecting our desktops or web servers to big data, but increasingly we're seeing the deployment of libraries of spatial analysis software right next to the data lakes and data warehouses where big data exists. These are massive tabular databases, sometimes imagery, or real-time, the result of tabular databases coming from real-time data sets. And so the very concepts that GIS people are familiar with are being now applied to these multi-billion observational data sets. And it's creating a whole new kind of understanding looking at historical patterns. Advances in imagery and remote sensing are no stranger to those of you in Australia. It has long been a place for innovation. But what we're seeing is a whole spectrum now of integration, not just imagery as base maps, but oriented imagery, being able to be managed by a GIS, being able to read in full motion video and do dynamic in-stream processing of imagery so that we create information products, point clouds, and reality capture of imagery in 3D like we've never been able to do before. And this isn't just an independent activity. This means image analytics and image processing are built right into the very same platform. I don't have to be an image specialist and a GIS specialist anymore. It's really knowing geospatial science, and that's quite exciting. Also, GIS is enabling 3D systems of record. This is perhaps a concept that you're not familiar with. Some of you will be familiar with it, the idea of creating a digital twin of a complete city in 3D. Your colleagues up in Singapore or in Hong Kong, across the world really, are beginning to realize that my 2D system of record, where I'm doing updates and transactions, can be enhanced with complete 3D objects instead. So I can add a building and it's a transaction on a database, maybe coming in from a BIM file, and immediately the rest of the users, engineering users, planning users, can immediately see the result of that long transaction activity. This is being enabled by 3D databases, 3D editing, and the sort of digital submission process of buildings, particularly in enterprise workflow settings. The next big trend I'll mention is the integration of game engine technology with these 3D twins. This means I can use a system of record as a base, or I can read in real-time sensors in 3D, or I can even fly over an area and create a reality capture, a kind of massive point cloud, and then look at it through the very interesting visualization and simulation technology of a game engine. Game engines like Unity can now be plugged in from GISs. And this means I can put on goggles if I want to use AR or VR operations, or I can stand around a table, like this one, showing 3D alternative plans for a city, and experience whole new realities, but not based on kind of artificial databases, the history of game engines, but actually the real digital twin in a GIS. Reality capture is a technology which allows me to fly a geography and create a 3D picture. And today, I can overlay that 3D picture on top of my 3D vector database. This is an example of that integration in Rotterdam in the Netherlands, where I point at a building in the 3D picture and it clicks and shows me the information about that building, which is stored in a system of record. Very exciting, actually, because it makes GIS more approachable. It's a 3D picture. This is a similar operation in Munich, and as I fly in, this was generated from an aerial set of aerial imagery. I extract a point cloud, I3S point cloud, and I can pan around this 3D picture. And this is vector data, OpenStreetMap data behind the 3D system of record, the reality capture, and I can get the attribute data about it. I'll just repeat it here so that you're clear. I fly, a couple hours later I process all the imagery, and I have it, voila, a 3D picture. And behind this 3D picture is the vector information, which could be transactionally maintained or linked to various tabular data sets of many types. This is now going to become the common standard 3D pictures inside of a GIS that other information is integrated with. For me, it's very exciting and makes GIS more approachable and interesting. Talking about approachable, GIS capabilities, all the hundreds of things that we commonly associate with a GIS, are becoming embedded as web services into other IT standards. Things like Salesforce or Adobe for graphics, or the Amazon cloud services, or inside of all of the Microsoft products, I can now use Power BI or Office to be able to access the system of record or GIS data directly and make maps as part of my workflows. Also, part of the exciting thing for me is the integration of GIS into Autodesk's products like BIM models and that sort of thing, where I can actually bring GIS into the design and construction process. That means empowering non-GIS professionals from across organizations and ultimately from across the world with the power of your sorts of work. Finally, I'll conclude with another trend about, we call it hubs. These are sort of portals and hubs which are opening up GIS operations to create communities of activity. These are all about initiatives that an organization like a city or a state or a nation may have, where I can recruit volunteers around maps and initiatives to do things. One such city is in right close to where I live, actually, Escondido, California. And they have 8,000 volunteers who are helping the city do their work. The city mayor is quite enthusiastic about this, and the city manager, because they're basically getting free work. Well, why? Because the citizens are becoming connected to their community in such a way that they can volunteer and participate. That's one end of the scale of these GIS hubs. The other end of the scale is, for example, agencies are getting other agencies to collaborate. Professional organizations like our emergency management organization is connecting with state and local agencies to be able to collaborate around something like a fire or a flood or a hurricane. And at the global scale, in my country, there are a number of initiatives started to be able to bring all the climate information for the planet together and share it with states and local and other nations, organizations, so that they can do their job better, leveraging the huge amount of investment that is being made in geospatial information to run government. All of these trends are exciting. I really want to conclude with a couple of final remarks. However, you and I are living in a challenging time, and our world is being challenged. And my sense is we, meaning the geospatial community, can actually do something about this. We need to be collectively responsible, actually all citizens of the planet, for its future. And the unique approach that you bring, your skills, the geographic approach, and this emerging geospatial infrastructure pattern, I really call it GIS at a new scale, is providing the science and the practical means to make a difference here. But the technology itself, even the good thinking that we have, is not enough. It's really to create a sustainable future, particularly you, and that's why I'm excited to talk to you, and your work will be essential. Providing leadership, bringing the sciences together, being able to develop problem-solving methodologies, you promoting the whole idea of geographic thinking and holistic thinking, and creating real solutions. This is so powerful. It's not just a technology thing. It's about bringing it all together, collaborating between each other, exchanging ideas, being able to communicate effectively, and especially going in with urgency. So thank you once again for this opportunity, and I wish you great luck in the rest of your conference.